16. I'm working in the cognitive radio area, also working with applied wireless communication to solve some contemporary solution for the elderly. So this is my area, but again, this topic is very prominent these days and very interesting. So I said, why not I join and meet new people. And thanks, William, for the invitation. Actually, I just, for that. Thanks a lot.
Yeah. And also I see Bobby.
Thank
Bobby,
you.
do you like to open your video and say something? Is Bobby also from our networking research group? And it looks you mute your microphone, Bobby. Or Wei Hua? I see Wei Hua is there. Is from our school? Is Wei Hua is you? No. Okay. I see Bobby is there. So where is Bobby? Yeah. I still try to learn the Zooms because Zoom has many configurations, and sometimes actually you can mute everyone, and then you just pick up the people to speak. But sometimes actually you cannot do that. It's quite interesting tools. Yeah.
Give you the feeling like you can be a dictator. You can
If
you want to shut up somebody who wants to.
But sometimes it's very interesting. When we have, because we have to switch online teaching, sometimes, but we use another is Blackboard Collaborate. But the issue is, sometimes if you open, everyone can talk, and someone, maybe they not in the desk, but they got noise, like the baby crying, and all the noise come in. So you have to mute everyone, and then you can let some people to talk, and some people actually forgot to mute. But it's something we need to face, when we use this online system.
Yeah, I saw several funny videos showing that when the professors or the high school teachers trying to give lessons to the student. Then, like you said, it's the background, not the noise. I mean the unexpected voice, like the wife is yelling at the husband, the kids is crying, and even the pets, so on and so forth. It's really fun. Yeah,
that's true. It's different, strange things.
And also the different platform has a slightly different way to organize things. So if you are forced to switch from this platform to another one on a daily basis, you may make mistakes. We're human beings, right? Human beings always makes mistakes.
So. That's true.
Yeah.
Bobby, if you unmute, you need to unmute your microphone. Actually, it's on the left bottom of your Zoom window. You need to unmute it. I think Bobby
unmute myself.
Now, you mute yourself. Yes, exactly.
No, I could. I don't know why earlier I couldn't unmute myself. Anyway, thank you for having this web seminar. Interesting to meet like this.
It's Professor Song actually really thanks.
Yeah, I hope that. Well, I mean, who knows? When we get too used to such remote things, we don't need vehicles,
Yeah, that's true. That's true.
But anyway, I'm. I think most of you know I'm a lecturer at the university here, and my research and interest area is in networking, and in particular security in networks and communications. So that's my primary research area. Well, hopefully, I think we can see that security is everywhere, and that I know of, maybe in future.
I really, it will be our pleasure if in the future Professor Song can visit us. And that will be great. You see,
I heard piano. Piano is playing. The background music. That's nice.
That's nice.
Like a Hollywood type of entertainment.
But now I have the power. Actually, I can mute. I can mute others. And also, I think the time is nearly there. I just like to give the notice that this webinar is recorded, so you should be aware of that. Okay, and also I need to ask you consent, but I think it should be most of you are happy with that. So I already started recording. Okay.
Oh.
We
so we should watch our mouth.
No. It's just from Agaba I started recording. Yeah, because a couple of my colleagues actually say apologize because the time is not fit for them, but they are quite interested on you talk. So that's why I really hope I can, record this. And also I see my department head Edmund is coming here. Edmund, how are you? Would you like to speak?
No, you go ahead.
Okay. Thanks, Edmund. Yeah. Really appreciate. Okay. So now I like to, if you are not the speaker, and I wish you can offer us a hand, you can mute your microphone, and then people actually can focus on Professor Song's talk. Today is firstly I really thanks you all join us, and especially Professor Song offer his time, give us this talk. It's a very interesting topic on the real light communications. And also I'd like to give two special thanks to Azet from Fiji, and also Paula from Tonga, and they can join us because as part of role of Professor Song, and he has a lot of works with ITU, and like Pacific Islands is also tightly connects with ITU, and we really hope in the future Professor Song can visit us in New Zealand and also like Fiji and Tonga, and we can have some research activity together. Okay. Now I like to, sorry. I think what I do is I will read the bio. Is Dr. Jian Song received his Bachelor of Engineering and PhD from Electronic Engineering Department, Tsinghua University, China in 1990 and 1995, respectively, with the first-class honor. He is now a full professor of the same department in Tsinghua University, as well as the director of Digital Television Technology R&D Center, one of the major technical contributors for the Chinese digital terrestrial television broadcasting standard. He is very active in serving the communities, such as being the associate actor of IEEE transaction on broadcasting, the leading associate actor for IEEE Access for the Broadcast Technology Society, and generally chair and TPC chairs for several IEEE flagship conference. Especially Professor Song also has great involvement with the International Telecommunication Union and is a WT6A vice chairman. He also served as the editor-in-chief of ITU Journal of Information and Communication Technology Discoveries, and the EIC of ITU Tsinghua Joint Journal of Intelligent and Converged Networks. And now I'd like to pass the time to Professor Song and to give us this talk. And we're looking forward to the interesting content there. Yep, Professor Song, yeah, please.
Okay. Thank you, William. Thank you for your kind introduction. I hope everybody is in the good healthy, stay safe and secure right now. I'm at the hotel room in Shanghai. After moving back from US to China last Thursday, I should do a 2-week quarantine. So that's why I have done this. I have to do this from the hotel. Hopefully the network will allow us to share our ideas clearly. And in the meantime, I'm still suffering a little bit from the jet lag. So therefore, if I made any mistakes during my presentation or during my introduction, please let me know during the Q&A session. First, let me change to the whole screen. Basically, the title of this talk will be the state of art, challenges and opportunities for the deeply integrated visible light communication systems. when I talk about the deeply integrated, means the visible light communication system can be a standalone. But in reality, right now, just like one technical book we just finished 1 month ago, we feel the best way to utilize the or fully take to take full advantage of VLC should be integrated with some other networks, existing networks, such as the wireless, for example, the 5G, or the power line communications as the backbone. So I will share these ideas later on. So this is the outline for my very short talk for about 45 minutes. The first is just the related research work. And then we're going to focus on this deeply integrated VLC system. And then I would like to summarize that and point a little bit about the opportunities for the futures. And then, like William just mentioned, we have a great involvement with ITU, especially for the academia publications. I will share some information with you. And hopefully later on, you would like to consider to contributing to those publications. So first, it's just who we are. And it's basically we're the major technical contributors to the Chinese digital television terrestrial broadcasting standard. Actually, the people in my group has certain quite different expertise. Other than the video compression or audio compression, we're more focusing on the physical layer transmission technologies, such as coding, modulation from the transmit side, and the receive side, the system synchronization, channel estimation, equalization, so on and so forth. Basically, we're the physical layer guy. So today I wear like the blue shirt, wear like the blue collar workers in the academia world. And also we do have a great involvement thanks to the Chinese government support for the standardization for the DTV area and also the broadband, power line communications, power line, visible light communication integrated systems. Regarding to our work or contributions to the ITU, we do have our standard being adopted. Ooh, I see, okay, okay, being adopted by ITU. You can see from this slide, the two documents, one regarding to these system parameters, and the second regarding to the deployment specifications are the two key documents related to the DTV broadcasting. And those standard, our standard has been adopted by ITU in the year 2011. And since then, I have a great involvement with ITU. And this is the honorary chair of the study group 6, Professor Mark Kovachev, really the big shot in this area. And he passed away in his in the year of 2019, I believe. Sorry, 18. And he was 97 years old. So which greatly encouraged me, saying if we're keeping our foot in the broadcasting industry, we could have a longer lifespan. Okay, and also I have been involved with ITU as the working party chair, vice chair, and as the sub-working party chair in charge of the broadcasting and the multimedia broadcasting. And later on, we have our advanced system. I mean, we improved the system parameter by taking advantage of the new technical breakthrough in this system and further improve the system performance. And this work has been adopted by ITU in the year 2019, I mean, December last year. And we also wrote a book published by Willie in the year 2015, which highlight not only just the our system, but also the other systems. I mean, from the technical perspective, especially focusing on the physical layer. Hopefully that provides a comprehensive understanding of all the core technologies associated with the terrestrial broadcasting, and also which we're kind of hoping to promote more or motivate more research work in this area. And for our system, we're not just drafting, I mean, we're not just developing the core technologies, just drafting the standard. We also work with the industry, with the whole agri chain to provide some tests. This is something done in China in the year 2018 and early 2019, demonstrating that using our system, the 4K, can be supported through the terrestrial broadcasting. This is in one city in China. And usually the data throughput is showing here is about 40 megabits per second. This is really the payload data rate, excluding all the overhead regarding to the cyclic prefix to mitigate the multipass effect, excluding the redundancy to help to recover the original signal free of error at the receive side without need the retransmission, and also exclude the overhead for the system information. I mean, every bit within this 39.5 megabits per second will be delivering the video information or audio information. And the coverage is relatively good. If you can see the map from the tower here, we can see the furthest one will be around 40 kilometers. If we use antenna of 10 meter high, we can receive that. And if you're in tall building, like what we have seen from our test, even over 50 kilometers far from the TV tower. But if you're lucky enough, you can have a live site transmission, you can still receive this 4K video or the program. And we did report that to ITU. This is a measurement we done both indoor and outdoor. And also we submit our work to ITU to share with the other colleagues. This is the first test in China, and then we conduct the second test in China is for the single frequency network in Hong Kong. This was done not last August, actually the August 2019. This is some testing equipment system parameters, and this is the arrangement for the testing. We have 3 transmitters locating at different locations in Hong Kong. And Hong Kong, provides us a very harsh and very complicated transmission environment. It's including the skyrocket high buildings. It has mountain areas. It also has the tidal effect. So therefore, it's a good place to test the performance, to check the robustness of our system. So we did the similar test like what we have done in Jiaxing, China. One for the fixed test, like you see from this slide, it's a 10-meter high tower antenna. And also we have conducted some mobile receptions in Hong Kong. This test is really interesting. Hong Kong people are really highly professional and highly efficient. I still remember back the year 2000, I believe 2006, 2007, when Hong Kong tested our first generation DTV systems. They make the good record of all the testing points and even the testing, the received signal strength. And now we did a similar test, but using the advanced system, using the much higher data throughput. It turns out that the mobile reception performance is relatively good. This is a good way to perform the testing and also give us a lot of higher confidence that our system is capable to deal both the fixed reception of the 4K or the mobile reception with high resolution. Of course, this is not the work done by just a couple of people. We do have a big team. This is the 12 faculty members in our group. Each are responding for, each faculty members have a special background. For the system perspective, we have coding guy, we have modulation guy, we have, like I said, synchronization, channel estimation, and so on and so forth. And also we do have people in the, which is specialized for the video compression. And this is a big family. Therefore, not only just the faculty members, we do have our engineers, we do have our students, and even we have second generation of engineer, possibly. Hopefully when they grow up, they will appreciate what we have done in this area, and will continue our work to bring more advanced technologies to further improve the system performance and deliver the better quality of service to the customers. So this is a very brief introduction on who we are and what we have done. The reason I spent some time to introduce that is the work we have done for the visible light communication system is not entirely new or didn't start from the scratch. So based on what we have learned, what we have accumulated from not only just the research perspective, but also from the hardware platform implementation perspective, and even some field trial, we'll be able to leverage what we have learned, what we have developed, and what we have gained from the past experience to move down to the visible light communications. I guess a lot of people knows this visible light communication, but I still want to spend a little slides talking about the benefit and the reason why VLC is considered not only just a viable solution and also being considered as the one of the promising technology for the 6G or the next generation of the wireless mobile communications. So one benefit is license free. Right now the RF spectrum is quite crowded. If you have paid any attention on the spectrum auctions for the 3G, I mean, it's about 10 years ago, it is over $100 million for these auctions. So spectrum is so precious and so scarce. So therefore, if we can have the new, if we'll be able to identify and explore the new spectrum range, that'll be highly desirable. So that's why people are talking about the millimeter wave, talking about the terahertz, not talking about the visible light or the optical. And second is the technology is green and safe. It's safe to the human being, to human body. I don't know if you remember, there was a research work conducted by several students from Scandinavian islands. They basically put some seeds near the Wi-Fi router and have another group of seeds far from this or being isolated from this wireless radiation or RF radiations. And a couple of days later or 1 week later, they found that the those seeds who have been receiving the radiation, theoretically they're dead. They're not being able to be alive. I mean, to put into the pot and grow like the flower or whatever. So that's why they claim that the radio frequency might be highly dangerous. I mean, if the strength is strong enough and if keep on radiation for 24 hours, 7 days a week, so something like that. And even in China, we had a similar funny story. The guy who had his wife been pregnant. So he knocked the door to his neighbor saying, hey, my wife got pregnant. So please turn off your Wi-Fi routers if you're not going to use that during the night just to be safe to the newborns, to new babies. So this is one reason. Another thing is from the security reason. If this is not electromagnetic wave and it's not going to radiate and it's not being easily been intercepted by the others. So this is not just only green, but also like security and safety issues. And third one is the deep coverage. You know, one famous professor in our area, visible light communication, his name is called Harold Harris. He's from the Edinburgh University. He made a very inspiring speech at the TED. He was claiming that there will be 140 billion LED lights, comparing with 140 million base stations for the radio frequency. And also considering the spectrum, he claims that if we use the visible light communications as a new way for the information deliveries or providing the information services, then the capacity will be 10,000 times higher or the better than the current existing RF-based wireless networks. But this is a big assumption that if you want to turn each LED lamp into a base station to provide the information services to the end users, you need to not only just consider the deep coverage of the LED, because every room now you have LED, and you also need to consider how to well connect those LEDs into networks. So like we had a base station, between base stations, we have the fiber or the microwave or whatever to make those base stations well interconnected. But how about the LED? So that motivated us, the research work, to utilize the existing backbone to provide the this interconnection. So that's why we said this deep coverage is a benefit, but also we need to consider how to make this interconnection well. But anyway, through these three obvious advantages of the visible light communications, it can play a very important role in quite different areas, and also had a very promising future, like I said, maybe 6G, and also in some very specific applications. For example, in a scenario where the RF signal is not available, or is RF signal sensitive or even prohibited, like the ICU in the hospital. And starting from this slide, I'm going to show you some work we have done in our lab. So from the high-speed transmission and localization, we have done some preliminary research work. We use the LED, white LED from the shelf. I mean, the one we can buy from the store to make this test. So we try to design a special circuitry to extend the bandwidth of this white LED from like only 12 or 13 megahertz to 162 megahertz. Like this is 10 dB bandwidth. And also we managed to do the offline transmission around or a little bit less than 1 gigabit per second in the year 2017. And then we successfully extend the bandwidth and also take advantage of this so-called color division multiplexing, use 3 colors RGB to deliver over 3 gigabits per second in the year 2019. Here, I should explain that because this is really at high speed. There is no high-speed circuitry available right now, so we use the oscilloscope to generate the waveform, and then to drive this LED, and the receive side will receive the waveform and compare the waveform difference offline. So therefore, we'll be able to determine the overall data throughput and also the bandwidth. Oops. Oh, okay. And we also did some live video transmission to use the VLC, PLC networks to use this LED lamp to do the video transmission. Before I continue, I would like to stop here and explain one key issues, which a lot of people in this area do have realized. But when the people from the other areas, at the very beginning, they thought we're using the light wave, they take it for granted that the visible light communication can enjoy the huge bandwidth, which is true in theory, but not necessarily true in practice. The reason why is if we are using the LED originally designed for the illumination, therefore it needs a higher optical output. Therefore, the PN nodes will be much wider, allowing more electronics turn into photons to enhance the illumination performance. But in the meantime, this has caused a huge drop for the resonance of this LED for the high-speed signal. In this case, the bandwidth is only about, like I said, 12 or 13 or less than 20 megahertz. It's not like 20 gigahertz or terahertz. So this is a huge difference. But of course, if we're not shooting for the illumination, we just say we use this light source to deliver the high-speed information. We don't care about this illumination effect. And also we can use some optical setup, like lens or so on and so forth, to accumulate or to narrow down the beam so that the long distance transmission can be implemented. But again, that is not from the commercial available LED. It's a special design LED. So that's why when we conducted our research work, when we built up our experiment setup, when we publish our papers, we do focus on using the illumination network, using the LED from the illumination network to deliver the information service as the value-added service. It's not like a brand new optical network solely designed for the communication. So this is a major difference. Of course, each group or each people, when they conducting the research work in this area, they do have their different focus, which is good, which benefits the whole community. And I would like to make this clear right now, okay? And also, this is something we have done, very cute experiment in our lab. So basically here, you can see here, we do have the video player, and the video player will send the TS, transport stream, to the PLC modem, and the PLC modem will do the coding modulation, so on and so forth, and convert the signal, inject the signal into the power cable, which is about 100 meters long. And then this signal combined with the low frequency, high voltage signal, I mean the AC, to this lamp. And this lamp will have a coupler to couple the information signal and also use the low voltage AC signal, the low speed, high voltage AC signal to power this light on. And then this high speed signal will linearly superimpose with this DC signal, I mean the optical signal to illuminate the light. So from that perspective, you can see the light will be transmitting from here to the photodetector here. And the light here transmitting from the LED is now highly fluctuated with its intensity, but the fluctuation speed is so high that our human eye won't tell. So at the receive side, we just did the opposite. We convert the optical signal into the electronic signal and then do the demodulation and then display that on our screen. So this distance could be as long as 8 meters. And you can still have this high speed, I mean the broadband video signal being well received. And we also consider the mobile reception. So here is a light on the ceiling, which can transmit the exactly what we have seen on the previous slide, the video programs. Of course, this speed is really high, and you won't, if you look at this light directly, you won't see the light variation in terms of intensity. But in the meantime, you can use this on-the-go device to receive this one on your tablet, and then you can watch the TV programs. But here, you need to keep a line of sight transmission environment from this light to this on-the-go device. Otherwise, you have to rely on the reflection lights. The speed, high speed won't be able to support it. But still, you can get the low speed information, like, for example, the temperature or something. But anyway, that's the advantage of this visible light communication, and also disadvantage of this visible light communication. The better you have a line of sight propagation environment to ensure the better reception performance. And with that, we have done more tests in our lab. If you are familiar with this digital signal processing, basically, this is a typical way to do the transmission. When you have the information bits here, you add the redundancy using the 4 error correction coding, you do the serial parallel conversion in order to perform the OFDM modulation later on. You do the constellation mapping and then map all this signal to be transmitted in the frequency domain. And then you do the IDFT to convert the signal into the time domain, then parallel to signal to serial, and then add the sector prefix or the guard interval to form the signal frame. And then you do the digital to analog, use the coupler to do the parallel communication. And at the receive side, you pretty much do the same thing here, just the opposite. I mean, in principle. So this is the entire setup. And thanks to the hard work of our people, not only just our faculty members, but also our research staffs, our engineers, and even our students, will be able to make this whole hardware by our own, and we can arbitrarily change the parameters to see the impact of those parameters on the overall system performance. This is really nice. And this is something I would like to share with you. So you can see this is the EBM before the transmission, and if you check the spectrum of the signal before the transmission, is really flat. It's the typical OFDM signal spectrum. But after this visible light communication and the power light communication transmission, you'll be able to see the frequency response is no longer flat. The spectrum is like tilted. So therefore, we need to do some equalization to make this pre-distortion showing on the blue line on the bottom of the right on this slide, so that after transmission, the red line is no longer tilted at the low amplitude from the low frequency, high amplitude at the high frequency, it's become relatively flat. With that, you can see this constellation mapping, even after this unfriendly transmission environment, you can still see there is a clear distance. Euclid distance is still maintained. Otherwise, we may see a lot of arrow symbols eventually turns into the arrow bits, which jeopardize the overall system performance. So after demonstrating that, we're trying to mimic the real scenario, because in the room, if we're going to use the visible light communication technologies, you need to consider the effect of the illumination, which means your receiver may not only just receive the light from single LED lamp, but would rather to receive the similar light from its neighboring lamps. So therefore, we did this measurement in our lab. Instead of having, it's pretty much the similar one like what we have shown before. Is instead of having just single VLC link, we do have 3 VLC link. So 3 lamps, all shedding its light to this APD is the photo detector. And then we pretty much to check the performance with the signal quality after we receive the signal, 1 as a desired signal, the 2 as interference. Okay, so again, we pretty much conduct a similar measurement. You can see originally the spectrum should be something like a flat, but if we do nothing from the transmit side, it's no longer flat in terms of the spectrum of this OFDM signal. You see many ups and downs. It's like a multipath impact, but it's not the real multipath. It's more or less like an artificial multipath introduced by the other 2 lights as the unwanted signal, or as the interference signal. But if we are able to do some equalizations, like we see, we'll be able to change this constellation mapping before this equalization to this equalization. So you will see there is a difference. That means the performance, if we decoding, demodulation, the signal like this, we still have a better chance to recover the signals free of errors. That's exactly what we have seen from our measurement. And based on that, we have published some papers in the related areas. It's not just a simple theoretical analysis by assuming the channel is a Lambert channel, by assuming the LED has certain field of view, by just assuming that the noise are Gaussian AWGN. We actually trying our best to mimic the real illumination scenario with a different noise, like the shot noise and so on and so forth. And also, we use 3 different lights to do the video transmission. You can see this is a 4K transmission, and on the screen, it shows a multi-video programs. At this moment, because of we are not being able to design the high power driver, so the transmission distance is not very large, but hopefully in the future, we'll be able to extend this transmission distance with collaboration with the people in the broadband driver design area. And then I would like to spend a little time introducing our idea for the networking using the VLC. So basically the idea is originally you use the PLC to provide the power to LED and also to the other electronic devices. And then you use a fiber or coaxial cable or whatever to deliver the information. Okay. So the problem for this type of layout is you need a new layout. It's quite complicated. And also because in this case, different users will provide the different information within certain coverage areas of LED. When the people move from here to here, you actually need to consider the handover. So that's caused a lot of issue. And in our case, basically, we're replacing the coaxial cable or the fiber with the power line. Instead of forming just a local cell, we're forming a local area network within one room. So all the LEDs are transmitting the same signal. So with this case, the frequency handover is not necessary. And also the deployment or implementation is relatively simple. So this is some benefit of using this, sorry. Yeah, and also provide us great scalability. especially for those houses without other information infrastructure, will be able to do that with this simple so-called amplified and forward mode of the network layout, integrating both the VLC and PLC. And in order to make this idea fly, we need to consider some real scenario. The first is how to allocate the spectrum. For the PLC, anything below 500 kilohertz is for the automatic meter reading. And we basically use this 500 to 2 megahertz for this localization to do this indoor localization and navigation. And anything about 2 megahertz is for the high speed. This is for the PLC, and similar thing is for the VLC. With that, we'll be able to implement our AF idea, or amplified and forward, because you don't have to do the decoding demodulation of the information from the power line communications and then do the modulation and the coding again for the VLC. You simply receive the signal from the PLC channel and doing the amplification on that, and then inject into the VLC, or use this signal to drive the VLC driver to deliver the information optically. So that's the whole idea in terms of the spectrum allocation. And of course, there's a lot of research work. When I say we're focusing on the implementation, it doesn't necessarily mean there is no research work, because the channel is no longer like a single VLC or PLC channel. It's a combination of the VLC and PLC. You need to consider a lot of things like the LED characteristics, the channel of the power cable, the channel of the visible light channel, including the multipath reflections, and the noise is no longer linear, non-Gaussian, non-attitude, because you may have known that for the optical, when you convert the optical signal into the electrical signal, you also suffer from the shot noise. This is apparently now the Gaussian noise and no longer linear attitude. And also you need to consider the receiver location, because if you tilt your location, because for the receiver, the photo detector needs to face the light perpendicular. Otherwise, you may reduce the overall optical power received by this photo detector. So you need to do a lot of modeling work to characterize the overall system channel in order to make sure that your design can be verified theoretically, and then later on, after the implementation, you will see your performance quite similar as you have predicted through your theoretical model. And this is for the indoor positioning. Again, each LED will have a unique code, and you can use the CCD of your cellular phone, or you can use the camera, or with help of some other devices, you'll be able to achieve the high accuracy location. We have done some experiments. The accuracy is about 2 centimeters. I think which might be good enough for the robotics when it's moving around the house, do some cleaning, and then going back itself, docking there to charge itself. Because in this case, you really need this very accurate location. And also, like I said, our original background was in the coding modulation, so we have done a lot of research work in this area. Because of the time limitation, and also it's quite detailed information. I'm not going to talk too much about that, but basically we're trying to combine the coding and the modulation together to enjoy the benefit of this combination to improve the overall system performance. One thing I would like to mention that low density parity check code, LDPC, has been adopted by 5G and other systems. And recently, we found a paper saying that the specially coupled LDPC can provide the uniformly channel capacity approaching performance, which is kind of interesting. And we're not making these observations, but we're trying to make the implementation of this idea more friendly. So the idea is LDPC is a block code. And for the error coding, for the coding, we do have the barcode and the convolutional code. Each has different characteristics, and apparently they have different performance and its pros and cons in the different applications. The idea for the SCLDPC in principle is trying to combine the block code into, try to convert the block code into a convolutional code. So one unit is a block code, and then between two units, we use a convolutional code structure, trying to leverage the benefit of both LDPC code, the block code and the convolutional code. The reason why we can do it right now is thanks to the latest development or technical breakthrough in the semiconductor, we'll be able to pay the price for the complexity, but in the meantime to enjoy the benefit of the performance improvement. So this is the idea. We also consider the different ways to do the multiplexing. This is one way for the for the non-orthogonal multiple access. We use a bit level for within one symbol, different bits. If you're familiar with the information theory, you'll know that the different bits within one symbol has different channel capacity because the Euclid distance is different. So therefore, we take advantage of that to provide or to propose one non-orthogonal multiple access scheme, which has been implemented in our lab. From this figure on the left side of, on the right side of the slide, you can see the performance is different. Therefore, we can use this idea to change the channel into two different type of services, making them non-orthogonally multiplexed. One to deliver the high speed, I mean the fixed reception, high definition TV, another is for the mobile reception. And also we consider the frame structure to support, very importantly here, using the idle slot for the light intensity adjustment. This is for the very important because again, like we said, we are focusing on using the existing illumination infrastructure to deliver the information, but as a value-added service. We're not trying to build up a brand new illumination networks. So therefore, we need to consider if, just in case we need to turn off the light, how we'll be able to maintain the low level, I mean low speed communication link, but in the meantime, it's not forced to turn on the light. I mean, in this case, the light is actually on, but the light intensity is so weak that human eyes won't tell. So that's why we can still maintain certain link. And also for the network convergence, you need to consider how to combine with the wireless or so on and so forth. And also from this perspective, you need to consider the network security issue. But unfortunately, like I said, all my colleagues, none of my colleagues has a background in this area. So we look forward to collaborate with people in this area who are interested in this new network structure, and we may collaborate together to see how we can maneuver our effort together to promote this network structure. So with that, we pretty much finished the high speed and communication type of VLC system. We're now trying to share with you like our new idea for the Internet of Lights. So basically we're trying to consider to use the existing illumination network structure to help provide the Internet of Things type of services. So this is one thing listed by the people in the illumination areas. So showing here, the lighting using the LED or semiconductor technologies can not only just improve the energy efficiency, but also eventually help to improve the wellness of human beings. Of course, the different time we have different focus. So we're now about in the middle of that. So saying that we're not only just focusing, we should not only focus on just the intelligent lighting, but also consider the wellness for the human beings when using the semiconductor lighting technologies. So the idea for this Internet of Things lights consists of three things. We're not going to read all these things, or I'm not going to read all these things, but basically one thing is to do the sensing. You're trying to get the information as much as possible by using the LED lights as a sensor node. And then you use the different technologies or the existing network infrastructure to transmit all this collected information to the operating center. And through this data analysis or the artificial intelligence or so on and so forth type of data processing, the command and control signal will be sent back, and then eventually to improve the wellness of the human life, or we call the humanistic light. And this is the I shouldn't say our vision for the future Internet of Lights, but basically our idea can be explained here. So I apologize, there's so many words, text here, but I will try to explain that based on what we have seen on the previous slide. So the light here is no longer just LED and AC/DC power module. Now you have the sensor, you have the MCU, I mean some processing capability, and then you have a PLC wireless communication, you have communication capability. And then for each light within the room, they formed a network. It's called the Internet of Lights. And then for the rest of things can be done through the gateway eventually to the operating center. So that's why we thought this can be considered as a triple play. We use this network to provide the illumination first. Of course, we can help to improve the wellness for the human beings, but it's also provide the information like the services, and also the power delivery can be done by this structure directly through the power cable. So this is something we feel it might be practical, a practical solution for our future for the intelligent homes. Okay, and also the European Commission under the Horizon 2020 programs, we have successfully we have been successfully awarded with a project called Internet of Radio and Light. It's a software-defined home network architecture. We collaborate with some European partners, work together to build up these servers within home. We basically use 5G or millimeter wave and the PLC as a ways to do the information transmission for the high speed to support quite different application scenarios, such as the museums, such as the store, such as the subway station, and even the office building to provide the in-depth coverage and high-speed coverage of the indoor application environment. And we also presented our work at ITU. It receives a lot of attention on that. We're kind of hoping with the successful conclusion of this project, I mean, which is due by next March, we'll be able to get more interesting results and share with the people in these areas. And our work with this VLC and PLC network had also won us the International Invention Award, I mean Gold Award for the first class in the year 2019. And one interesting thing before I finish my presentation is we say that by combining the power networks, by combining the power networks with the illumination networks, we'll be able to build up the Internet of Lights, right? To provide the information services as a value-added service for the Internet of Things type of applications. But people really want to do more because we're the research-oriented universities. We really want to see what other benefit can we dig it out from this infrastructure. So we have came across with some publications saying that the light can provide a new or novel way for the non-intrusive optical therapy, which help to prevent people from some degenerative disease and even to help to relieve the AD, Alzheimer's disease. So following their work, we're kind of thinking based on our instructor, we may be able to do some experiments to see how our platform, IOL platform, can support this. So here is the motivation of our experiments. This is a setup. We do have some mouses which have been implanted with some electron nodes, and then we use the software to record the brainwave of this mouse. We then use the VLC, use the light with a different duration of the modulated signal at the low frequency to radiate the mouse and record his movement, record the brainwave, and kind of hoping that those mouse will react to certain low frequency radiations of the light. And eventually we'll be able to link this brainwave radiation with the heal of some disease. So this is the whole idea for that. And we have done some preliminary results. We do have two mouse under the test. You can see the horizontal axis is the frequency. This one and this one, the first figure and the third figure are showing there is a spike at around 20 Hertz, while the second and the fourth is no. So the first one and the third one is the brain wave of the mouse after being radiated, while the second and the fourth is not the before this. So we will see some charge or some charge and discharge process when this radiation happens. And if we do some signal processing, you can see on the first figure on this slide, around 20 Hertz, you'll see a clear white line, which means this charge is really strong and noticeable. And this is very preliminary results showing that there is certain effect of the low frequency radiation of the LED on the brainwave reading of the mouse. And if you are familiar with this area, you can see the different brainwave actually corresponds to the different state or the mode of the brain. So we're kind of thinking that maybe if we conduct further research work or investigations in this area, we can gradually accumulate enough information or data, and later on we can see this radiation can be, this brain wave can be stimulated with the radiation of the LED. So this is from one way to think about that. And another way is if later on the visible light communication technology has been adopted for the communication standard, especially when utilized indoor, we need to consider the possible impact of those communication service on the human brain activities. So this is another way we look at that. Luckily, our very preliminary results or the work has been adopted by the Standard Communication magazine. Last night, I've been working really hard to finalize that, and the final date for the accepted paper submission is around 12 p.m. today. So my colleagues are helping me to upload the file. And in summary, I'm going to make a very quick summary. I guess I'm running out of my time. There is a natural combination of the power cable and illumination network. So that's why we propose this VLC, PLC networks. Of course, there is other integrated networks, like I said, with visible light communication together with 5G. And we believe if we're particularly targeting the VLC, PLC, or the 5G VLC, the AF mode is more suitable to avoid any complication of the hardware implementation and also the frequent handover when the user is under mobility. And still, like I said, even though we're a big group and we have done some work, very preliminary work, still a significant amount of work are needed. And we're looking forward to collaboration with the people from different areas, but are quite interested in the VLC type of systems, applications, and even this theoretical work. We would like to welcome all these colleagues to work together to make some real impact later on. And then, like William mentioned, I'm going to use the last several slides to quickly introduce my role as editor-in-chief for the ITU academia publications. You know, ITU has a history of over 150 years. There is no academia publications before, while the Secretary General of ITU strongly believes that in the future, the standardization will strongly tie with innovation, while the innovation comes majorly from the research institute and academia community. So that's why he had this brilliant idea to have this journal. And in the year 2016, we do have a consultation meeting with the Secretary General of ITU, Mr. Zhao, and to come up with this idea. I believe William was also there in Bangkok, Thailand. And in the very early of 2017, we created this journal, these publications, and now it runs on well. The first journal was, the publications was officially launched in September 2017, and it was in AI. And then data science, radio wave propagation, and video multimedia type of area publications has been followed. The only challenge for this publication is it's really subject-based. So depending on the theme of each special issue, you need to pay close attention on that. If that will fall into your research area, you may consider to contribute. And after 3 years of my work, I'm now passing this role to another professor, which is a retired professor from Georgia Tech in US. Now he's running this journal. And we create another journal with the help of ITU, which will be more focused on the communication technology, or it's CT domain oriented. I quickly listed highlight this. So this is really the convergence. The title is called Intelligent and Converged Network. Converged network more or less is CT domain oriented. It's called broadband broadcasting or convergence, wired and wireless, satellite, optical, communication, control, communication and computing, even the convergence for the cyber physical systems for the different applications like IoT, like the state grid and so on and so forth, or smart grid. And also we're not excluding the novelties or the innovations from IT based. I would rather to welcome the convergence between IT and CT, such as AI and blockchain and maybe so on and so forth. We encourage those convergence. So that's why we do put the intelligent into the title of these publications. With that, I pretty much finished my presentation. I apologize, I'm like 5-10 minutes late, and I'm now ready for your questions, and thank you.
Oh, thanks, Professor. Actually, it's not late. It's really good, very informative talks. I see a question actually from Professor Hu. So Professor Hu, actually, we don't have too much people. So do you mind actually, you can raise a question, just turn on your microphone. So can you hear me? Actually, Professor Hu's question is, I see where it is. Okay, I see there is another. Is how likely can we use the light to achieve the combined wireless power and the signal transfer to wireless sensors?
Okay, thank you for the question. Let me understand that. So the idea is to use the optical to do the information transmission, but at this moment, if you're asking to use the light to do this similar type of energy harvesting, I don't know yet. But maybe, because eventually it's energy, but it's like a very sophisticated mechanism, because when you convert from optical to electrical, you do have certain efficiency. You actually lose some received power. So if I understand Professor Hu's question correctly, the power delivery is only to use this electrical power to power on those electronic devices like LED lamp, like the other electronic devices. It's not for the optical power converted into the electronic power, like the wireless power transfer. But while the information can be delivered, use the visible light communication in a more green or energy efficient or like safe and security way. Thank you. I hope I understand your question.
Yeah. Thank you, Professor. Okay. Very nice talk. Yeah, very nice talk. Yeah. So basically, I'm working on. We have a group here working on wireless power transfer. And for very low power, people start to use light to do wireless power to drive. There's a company actually doing it now, so they can deliver 1 watt across about 10 meters, over 10 meters. They're pretty good. So if we can combine the power and the signal to achieve a complete autonomous sensors or actuators, that would be very useful.
Well, that's a brilliant idea. Now, because you do have some experience in this area. Yeah. Why not? Because you can make we can make it more content type of ecosystem. Yeah. Okay.
Yeah.
Nice.
Thank you. Nice.
Yeah.
Okay.
Okay. So thanks, Professor Hu. And also I see Saeed is here. So do you like to raise your questions?
Can you hear me?
Yeah, yes. But I hear very strong echo.
Okay, so I'm using a mic. I don't have a. Okay, yep, I can hear myself as well. So it's a strong echo. I'm not sure how to figure it out.
It's okay.
Yeah, should be okay. Should be okay. We can hear. Yeah.
Are you there?
Yes, Saeed, are you there? It should be okay. I think it's okay.
Okay, okay. I mute myself, so
Yep.
I was just talking. Thanks for the informative talk. I will just repeat again whatever I have said. My question is related to the handover. If all LEDs are like transmitting the same information, then I believe multiplexing neutralized over there. What about the scalability issues? Like if we have hundreds of LEDs and we are transmitting the same information, then what is this LEDs that they are broadcasting the information? Then the security issues come with it because someone in some other room, they can listen to it if it's not scripted. Even if it's scripted, then they can listen to it. So that is one question. And then the other question is related to the limitation of the PLC, because that is a bottleneck. So it has around like less than 1 gigabits per second. So if we have the VLC, it can like provide up to 15 gigs of speed data rate. But if we are using the PLC, then that's create a bottleneck. So those are the two questions that I would like that if you can just comment on that.
Okay, thank you, Saeed. I can hear you clearly. There's two questions. The first question is regarding to the handover. If just in case you have hundreds of LEDs within the room, if all the people are sharing the same resource, then the benefit of avoiding this handover may not be good enough to compensate for the benefit you lose the capacity, right? Yeah, you're right. So that's why I'm saying that within the building, it's highly unlikely within the room you have over 100 lights. So therefore, you have pointed out correctly, we're not shooting for like a huge room or like a convention center. Then every LED light will transmit the same signal. So you could, just for argument's sake, you could form a slightly different local area network. You use the neighboring LED lights to transmit the similar signal or the same signal. While for the rest, you can form another local area network. With that, you are not fully eliminate the need for the handover, but you greatly reduce that, especially when the mobile users, they are not moving very high speed. So you can still enjoy the simple structure of this VLC, PLC using the amplified forward mode. But like you said, you point out that's absolutely correct. You may not fully enjoy the benefit of the handover free. So this is my answer for or my comments for your first question. And second, you're right. It seems you're very familiar with the PLC technology. Yeah, you're right. For the PLC technology, it's more like using the existing power delivery network to do some information transmission or type of thing. So that's why for G.N, you have a brand new PHY, which only support like 1 gigabits per second. So if later on we are shooting for huge capacity required to support the VLC, then this PLC as a backbone, this idea will not fly. You're right. So in this case, you really need to consider to use the fiber or other things. If I remember correctly, when I mentioned this European project, we work together with other people for the 5G and VLC. This is one way to do that. Another way I heard from my European colleagues saying there is a company, I forgot whether it's from Israel or it's from Switzerland. They have the fiber, they have a converter to convert the lights from the fiber to LED. I don't know whether it's mature enough or but eventually we do have different ways to help to interconnect the LEDs and then to build up the network using the VLC technologies. So power light may not be suitable for all the scenarios. It's only good with the small scale network with not very high speed. And another interesting thing is when people talking about using the VLC technology is based on the OFDM, right? Because the light we can only modulate the intensity. So the OFDM technology usually you only use some subcarriers. The subcarriers with index of the odd will be carrying those things, while with the even index will carrying the information. So people are thinking to split that, you will able to form like layered network, which means for these used subcarriers, we can form like local area network carrying all the information. While for those uncarried subcarrier, we use a very low signal strength to support the local services. But again, for that one, I have came across some papers. We haven't seen any implementations on that. But anyway, these two are very good questions. Thank you, Said. Hopefully my comments help to clarify some things. Thank you.
Thank you for your answer. Yep, one of my students, we are working on the scalability issues that you mentioned, right? That we are working and have some familiarity with this area. So I will be in contact with you later on regarding this problem. Thank you.
Yep.
Thank you.
Yep. Thanks, Said. So how about others? Any questions from others? Okay, so basically, if you like to connect with Professor Song, you can check his emails, and also, if you like to ask for this video, you can also send the email to me, and we are very happy to share this record video, and you can also feel free to share with your colleagues. And usually at the end, we will present a gift to the speakers is AOT branded bamboo power bank. I know
wow.
is Professor Song is very energized. So, but we hope we find the time. We can pass it to you, or you come to our New Zealand and we can really hand to you. Face to face. Yeah.
I would love to. I would love to, and I hope that the technology moves so advanced. Then when I try to, when I come to New Zealand to get this, it becomes the power bank using the light instead of just wireless power transfer.
Yeah. That's so actually that's exactly Professor Patrick Hu actually is working. Yeah. So it's nice if you guys can meet, or you can I know it's still COVID-19 is not permit, but it's good we can set up these connections. Okay.
Yeah, I look forward to that.
Yeah.
And also before I finish, please consider to contributing to these new journals wherever you feel your research work might be well to share with people's. I mean, we can use the ITU platform to help promote your work. Thank you so much. I really appreciate that. Thank you, William. Thank you all the audiences. Thank you for your kind questions.
Yeah. And also I will pass this journal to Professor Patrick Hu because he is working in the power area. So it's good to see the different disciplines, can meet each other. Yeah. Okay. Thanks. Thanks for your time. And if you like to, follow up with Professor Song, and you can send an email to him, or you can through us, is whatever you feel comfortable. Okay. Yep. Okay. So good afternoon. Yeah.
Thank you.
See you.
Enjoy your September.
Okay. It's a little bit cold here. Okay.
Oh, really?
Yeah. Okay. See ya.
Okay. Bye.
Yeah. Bye.